Good morning to all of you. In this lecture, I am going to discuss the concept of degree of freedom. In previous lecture, we have discussed the basics of classical mechanics, what is the advantage of classical mechanics over the Newtonian mechanics, and we have already discussed the concept of constraints and generalized coordinates. So in this lecture, I will discuss about the concept of degree of freedom, that is what is degree of freedom, how to calculate the degree of freedom mathematically, and how to analyze the concept of degree of freedom physically. So degree of freedom is basically the number of independent coordinates required to specify the motion of a dynamical system, or in another word we can say that how many number of independent ways the particle can have motion. So degree of freedom is simply how many number of independent ways the particle can have motion. This is very important parameter, independent ways. So how many number of independent ways the particle can have motion, or how many number of independent ways the particle, or how many number of independent coordinates required to specify the motion of dynamical system. So this is the definition, and mathematically expression, we can express our degree of freedom mathematically, which is simply denoted by symbol d. Degree of freedom d is simply 3n minus k, where this n is number of particle used in the system, and k is number of equation of constraints used in the system. Number of equation of constraints used in the system. So this is the mathematical expression. Now let us understand the concept of degree of freedom. For example, or through examples, suppose we have a single particle in space. So single particle in space, so let me write here example 1. A single particle moving freely in space. So what is the degree of freedom? We have a single particle which is moving freely in space. So what is the degree of freedom? So what is degree of freedom? So this is the questions, and we know the degree of freedom is defined as, so solution, we know that degree of freedom d is simply 3n minus k. So what is our n? N is the number of particle used in the system. So we have single particle means n is 1. So one particle in space, and geometrically we can also express that. Let's say this is single particle whose coordinate is x, y and z, and this is, let's say this is x, this is y and this is z coordinate. So this particle in space, so we have n is 1. And what about k? K is the number of equation of constraints, and I have already explained the concept of constraints, which is restriction to the motion or limitation to the motion. But there is no constraints, because we, in example, we have information that a single particle moving freely in space. So there is no constraints. So there is no equation of constraints corresponding to this example. So therefore k is 0. Number of equation of constraints used in the system is 0. And what about n? N is simply 1. So degree of freedom is 3 into 1 minus 0, which is 3. It means there are 3 independent ways the particle can have motion. So particle move along x-axis independently, particle can move along y-axis independently, and particle can move along z-axis independently. So this is the way to find out the degree of freedom of a single particle moving in space. So let us understand. Now we have another example. A single particle, two particles moving freely in space. So next example 2. Two particles moving freely in space. Then what is degree of freedom? This D is degree of freedom. Now in earlier case we have a single particle. In this case we have two particles moving freely in space. So we know that degree of freedom is DOF, degree of freedom, or D is simply 3n minus k. Now we have two particles. Let's say this is P1 and let's say this is P2, and corresponding coordinates is, if we have particle 1 in space, so we have x, y, z. Now we have two particles, so write down the corresponding coordinate. This is x1, y1 and z1. This is x2, y2 and z2. If it is moving, this is x, this is y, and this is in space. So what is the degree of freedom? Again, degree of freedom is defined as 3n minus k, where k is the number of equation of constraints used in the system and n is the number of particles. So in this case we have n is 2. Again there is no constraints to the motion, because in example we have information that two particles moving freely, so there is no constraints. Again the particles moving freely, which means there is no constraints. So k is 0. K is a number of equation of constraints. So k is 0. So D is simply 3 into 2 minus 0. It means there are 6 independent ways the particle can have motion. So there are 6. So this is the mathematical way to find out the degree of freedom of a system, of a single particle or a system of particles. So there are 6 independent ways. Now if we have a n number of particles, so we can generalize this. N particles moving freely in space, then what is D? N particles moving freely in space. So again, moving freely in space means there is no constraints in our system, in our chosen system. So again, degree of freedom is simply 3n minus k. So k is 0 and number of particle is n. So degree of freedom is 3 into n minus 0. So which means there are 3n dependent ways the particle can have motion. So for one particle we have 3 independent ways. For one particle in space we have 3 independent ways. Means degree of freedom is 3, which means we have 3 independent ways to specify the motion. Our particle can move in 3 independent directions. And if 2 particles, so particles have 6 independent ways. And if there is a n number of particles, so there are 3n independent ways the particle can have motion. So this is the way to find out the degree of freedom of a freely moving particle. Now what happens if the constraints present in the system? What happens if constraints present in the system? So we have already explained that constraints is the restriction to the motion. So if the constraint present in the system, then how to find out the degree of freedom? So degree of freedom in presence of constraints. So now let us understand the concept of degree of freedom through constraints. So a single particle with the same example, a single particle moving freely in plane. In earlier case, single particle moving freely in space. Now we have example, a single particle moving freely in plane. So what is degree of freedom? A single particle. Now we have information about plane. It means now we are restricted, the particles are restricted to move in plane instead of space. In earlier case, single particle moving in in space, but in this case particle moving in plane, means there is a restrictions. Now this particle moving in plane, so this is x, y, z. Now what is the degree of freedom? So again we have a formula. So mathematically, degree of freedom is simply 3n minus k, where n is single particle, so n is 1. And what about k? K is a number of equation of constraints. Now the particles are moving in a plane, means it is only moving in 2 dimension instead of 3 dimension. So we have to freeze one direction. So corresponding to this figure, it means z equal to 0. If particle is moving in xy plane, so z equal to 0. If particle moving in xz plane, then y equal to 0. If particle moving in yz plane, then x equal to 0. So consider in this example, in this corresponding to this figure, we can see that particle is moving in xy plane. It could move in any xy, yz, zx plane. So take this one. So particle moving in xy plane, which means z equal to 0. Which means z equal to 0. So this z equal to 0 is known as equation of constraints. Equation of constraints. So there is no any other constraints present in the system. So we have only one constraint, that is z equal to 0, and this z equal to 0 is known as equation of constraints, and there is only one constraint present in the system. So value of k is simply k. What is k? K is a number of equation of constraint present in the system. So in this case, we have only one constraint present in the system, because single particle freely moving in plane instead of space. So in plane, z equal to 0, so k is equal to 1, and n equal to 1 and k equal to 1. So degree of freedom is simply 3 into 1 minus 1. So particle can move in 2 independent ways. So there are only 2 independent ways the particle can have motion. So it's all about this example. Now we have another example, that is a single particle moving along a line. A single particle moving along a line, which means 1D, then what is degree of freedom? This is another example. A single particle moving along a line means particle moving only along one direction. So this is our particle. This is moving along either X, Y or Z. So what we have? We have information. What is our job? Our job is to read the example and try to find out the number of particles, and then try to find out the number of number of constraints present in the system. And third step is to substituting the value of n and k in order to find out the d. So d is simply again 3n minus k. So again a single particle moving freely along a line. So n is 1. And what is k? What is our k? K is the number of equation of constraints present in the system. So again a particle moving along a line means particle moving along one direction, one dimension. So particle can move either along x direction or y direction or z direction. So if particle moving independently x direction, then if this particle p moving along this direction, so what is our y? Y equal to 0 and z equal to 0. If particle moving only along a line, it means it can move either along x axis, y axis or z axis. So if the particle moving along x axis, let's say this case, then y equal to 0 and z equal to 0. So this is the equation of constraints. So in this case we have two equation of constraints present in this system. There are two equation of constraints present in this equation. This equation is known as equation of constraints. And what is the value of k? K is simply number of equation of constraints. In this case k is 2 because we have two constraints present. So this is known as equation of constraints, and k is known as number of equation of constraints. So k is simply 2. Now putting the value of n and k, what we have? 3 into 1 minus 2. See, this is the mathematical and this is the physical explanation. So mathematically degree of freedom is 1, which means particle can move only one independent ways. It can move either along x axis or y axis or z axis. So this is the role of constraints, and this is very simplest example to understand the concept of constraints. Next we have another examples. Two particles connected by rigid rod moving freely in space. Now we have another example. Two particles connected by rigid rod what is the degree of freedom? What is the degree of freedom? This is particle 1, this is particle 2. Let's say this is 1, this is 2. This is connected by rigid rod. This is the situation, or this is the example that we have, and we can extract the information that we have two particles means n is 2. So solution is simply degree of freedom is, how to find out the degree of freedom for this system? 3n minus k. So 3n minus k, in which n is number of particles, which is 2, because in example we have information two particles connected by a rigid rod. What is the degree of freedom? Now write down the coordinate corresponding to particle 1. This is x1, this is y1, this is z1. So this is P1 and this is P2 particle, and its coordinate is x1, y1 and z1, and this is x2, y2 and z2. It is connected by rigid rod, means there is a constant present in the system. So what is that constant? This is rigid rod, so distance between them is constant. So n is 2, and what is k? We have to find out the k. We have to find out the k. So what is k? Because two particles moving freely in space, so we have 6 degrees of freedom. In earlier we have already discussed that two particles moving freely in space, so corresponding we have degree of freedom is 6. But in this case, two particles moving freely in space which are connected by rigid rod. Rigid rod. So there is a constant present in the system. So what is that constant, and what is the equation of constants? See, equation of constant is very important. If you are able to write down the equation of constant, then you can easily find out the degree of freedom in presence of constants. So what is this constant? क्या restrictions है? Restrictions is simply the distance between 2 points. Distance between 2 points is fixed, because this is simply a rigid rod. This is not a flexible rod. This is not connected by a spring. If there is a spring, so we have another situation. But in this case, this is rigid rod. It means distance from this point to this point is constant. And how to find out the distance? By simply 10th class matrix, which is D equal to distance between 2 points is simply Z2 minus Z1 square plus Y2 minus Y1 square plus X2 minus X1 square, which is constant. So this is the equation of constant. This is the equation of constant. And what is there is only one constant present in this system, which is the distance between 2 points, which is constant. So k is 1. In this case, k is 1. So in this case, k is 1 and n is 2. And I hope it is clear to all of you, because in this system distance between 2 points is constant, which is constant because this is connected by rigid rod. So the k is 1. So this k is 1. So degree of freedom is simply 3 into 2 minus 1. So there are 5 independent ways the particle can have motion. So this is the way to analyze the. Now in the same example, if this is two particles connected by rigid rod moving freely in space, so its degree of freedom is simply 5. We have already evaluated. Now next we have another example, that two particles in space. If two particles in a plane are moving freely in a plane, are connected by a rigid rod. So let me, two particles moving freely in plane are connected by rigid rod. What is D? Means what is degree of freedom? So in earlier case we have a two particle in space which are connected by rigid rod. So in earlier case we have only one constant. But in this example, two particles moving freely in a plane which are connected by rigid rod. So we have this information. This is plane. So what is the equation of constants, or how many constants present in this example? So one is distance between, because this is connected by rigid rod, so one constant is distance between 2 points. Distance between D. D is constant, that is one constant. And this is moving in plane instead of space. So plane means Z1 is equal to 0, and since particle is moving in plane, so we can consider here XY plane, particle moving in XY plane. You can also consider YZ plane, ZX plane. So correspondingly we have different coordinates which is equal to 0. So if we consider the particle moving in XY plane, so corresponding Z1 is equal to 0 corresponding to particle 1, and Z2 equal to 0 corresponding to particle 2. Now we have, this is equation of constants. This is equation of constraints which are present in our system, or which are present in this example. So how many equation of constraints? 1, 2 and 3. So there are 3 equation of constraints present in this example. So we can write this K is simply number of equation of constraints present in the system. So K is simply 3. And what is N? So degree of freedom is simply 3n minus K. So N is 2, because two particles moving freely in plane which are connected by a rigid rod, and K is 3. So degree of freedom is simply 3 into 2 minus 3. So 6 minus 3, which is 3. So depending, now we have only 3 independent ways the particle can have motion. So we can see the role of constants. Role of, so increasing, in this case, in earlier case we have only one constant, so particle can move 5 independent ways. In this case we have 3 equation of constants present in the system, so particle can move only 3 independent ways. So that is the definition of constant, that increasing means if there are more number of constants, so there is a less possibility of moving a particle independently. So constants restrict the motion. Constants restrict the motion. So it's all about the concept of degree of freedom. In next lecture we will discuss about the concept of degree of freedom of rigid body.